Okay, so let's go ahead and get started with section 1.1 of Unit 1, Simplifying Expressions. 1.1 is going to cover the law of exponents with products. Okay, so make sure you have your note sheet as we go through this particular lesson. Okay, so now the objective here is that you should be able to simplify expressions using the product of a power property, and also simplify expressions using the power to a power property. All right, so let's start with some vocabulary. So what an exponent is. All right, so an exponent is a notation that indicates how many times a factor is to be multiplied by itself. Okay, so exponent is a notation that indicates how many times a factor is to be multiplied by itself. So again, I'm sure you're familiar with the concept of an exponent. Like for example, 5 squared, again, which means, right, we know that 2 is the exponent, right? 5 is that factor that needs to be multiplied by itself. Right, so again, we can 5 squared, we want to interpret that as 5 times 5. Or if we have something like 4 to the 3rd power, again, that's exponent is 3, the factor is 4, so it's going to be 4 times 4 times 4. All right, so again, another vocabulary word we need to talk about is, what do we call that factor? There's another name for that factor that's being multiplied by itself. When you're talking about an exponential expression, again, we know what we call these smaller numbers off to the top right. Those are the exponents. But these bigger numbers or bigger things off to the bottom that these exponents are attached to, that is called the base. Okay, so let's write that down. So a base is the factor that is to be multiplied to itself. Okay. Example number 1 says, use the definition of an exponent to expand and evaluate the following expressions. Okay, so again, to do this, we need to make sure that we know and quickly identify the exponent and what the base is. Here the exponent is 2, the base is 8, so that means 8 is that repeated factor, right? And so we're going to have 8 multiplying times itself 2 times, right? Because the exponent is 2, it's going to be 8 times itself 2 times. 3 to the 4th power. Oh, and we need to evaluate 2. Okay, so 8 times 8 is 64. Okay, remember, we're multiplying here. 3 to the 4th power. 3 is the base. So it's going to get repeatedly multiplied times itself. And because 4 is the exponent, we're going to see the 3 multiplied times itself 4 times. So 3 times 3 times 3 times 3 is 81. All right, 3 is the exponent in part C. The base is -4, right? Because it's in parentheses, the exponent is attached to the parentheses. The -4 is the base. So that is the factor that's going to get multiplied times itself. So we're going to multiply -4 times itself 3 different times. And then -4 times -4 times -4 is -64. In part D, -5 is the base. 2 is the exponent. So that exponent is telling us that we're going to multiply -5 times itself twice. Negative 5 times negative 5 is positive 25. All right, so now we're going to flip it around a little bit here. So now we're given the expanded form, and we want to rewrite it using exponents. All right, so we see that the 6 is being repeatedly multiplied. So that tells us that the base to our exponent is going to be 6. All right, now so we need to count how many times we multiplied 6 to itself. And we see there are 5 6's there. So that 5 is going to be our exponent. Part B, we have 4 times itself 3 times. So 4 is the base. 3 is the exponent because we see the 4 3 times. Here we have 3 multiplied times itself. So we're going to have a second exponential expression here. So this 3 represents this repeated factor of 3. And we see 3 is being multiplied times itself 5 times. So that's going to be our exponent. C, I have 1, 2, 3, 4, 5 x's being multiplied times itself. 1, 2, 2 y's being multiplied times itself. And just 1 z. Here we have 1, 5, and 1, 2. Now, rather than keep those two separated, I'm going to go ahead and multiply those together. So 5 times 2 is going to give us 10. I've got x times itself twice, so x squared. Y times itself 3 times, so it's y cubed. And then z times itself twice, z squared. Okay, so that's us taking the expanded form and rewriting it using exponential expressions. All right, so for this next part, we are going to try to evaluate this with a calculator. Okay, so it's evaluate expressions with the help of our calculator. All right, so now it's very important that when you are using a calculator to make sure you understand, right, that there is a difference whether you use parentheses or not, right? So part B, we have parentheses around the negative 6, and part A, there is no parentheses. So when you enter this in your calculator, it's important that, hey, if there's parentheses, you want to make sure you use the parentheses. Okay, so let's start off with part B, right? If you go to your calculator and you type this in your calculator with the parentheses, all right, again, that is telling us that we're going to take negative 6 times itself twice. All right, so again, whether you're using your calculator with the parentheses or if you write it out in expanded form, just like we've been doing, it's negative 6 times negative 6, which is a positive 36. All right, compare that to part A. All right, again, if you type that in your calculator without the parentheses, the way that your calculator is evaluating this one is that the exponent is attached to just the 6, right? That 2 of exponents attached to just the 6. That means that it's just the 6 that's being multiplied times itself. That negative is actually just kind of hanging around, waiting for 6 to be squared. All right? So 6 squared is 36. Tack on the negative, and that's how we get negative 36 from our calculator. Okay, so let me give you some time to do part C and D. Okay, so for both of those, you should get negative 8. All right? Again, for part C, we are multiplying negative 2 times itself 3 different times. So again, we could rewrite that in an expanded form like this, and that would get us negative 8. With part D, again, that exponent of 3 is attached to the 2, so and that negative is just kind of hanging around, so it's really 2 times itself 3 times, and that negative is hanging around outside by itself, and that's how it's going to get us negative 8. Okay, I'm going to move on down to part F and G. And when you're asked to evaluate problems like these, it's important, again, that you are using parentheses. Okay? So here we got negative x to the 5th. It says evaluate negative x to the 5th when x is equal to negative 3. All right, so what we know we have to do is plug that negative 3 in for x. So what we have to do is to make sure that we set it up like this, right? So that negative that's next to the x is that negative right there. That 5 is definitely that 5 as an exponent. So again, when we are plugging numbers in for variables, again, it's a substitution. We're taking that x out. All right, so I'm going to put a parenthesis here and leaving it blank. That's where that x was. And in its place, we are going to put a negative 3. Okay, so it's important, especially again, if you're using your calculator or allowed to use your calculator, that you approach it and rewrite it this way so you do the substitution correctly. You do the evaluation correctly. Okay? All right, so again, when we finish evaluating that, that should give us a positive 243. All right, so for the next problem, so again, we're going to plug negative 3 in for x. So that means everything else stays the same. That negative outside the x, that 4 is an exponent. So where x was, right here in my parentheses, I'm going to put negative 3 in its place. Okay, so when we evaluate that, that's going to give us negative 81. Okay, so now we're going to move on to the product of a power property. All right, so it says expand the expressions and rewrite using the exponents. Okay, so use the result to determine a general rule for multiplying terms with the same base. All right, so here we're going to take x cubed and we're going to expand that. So it's going to be x times x times x. And we're going to take that x squared and we're going to expand that. So that's just x times x. And we're going to multiply those two things together. Okay, so now we're reevaluating what we have here. And we see that we have that same factor of x being multiplied times itself 5 times. So that we can go back and rewrite that as an exponential expression as x to the 5th. Part B, we have x times itself 5 times, right? That's x to the 5th. We have x to the 4th, so that's x times itself 4 times. We're asked to multiply those together, so I'm going to go ahead and put a dot there, multiply those together. And again, we see 1, 2, 3, 4, 5, 6, 7, 8, 9 x's being multiplied together. So we're going to rewrite that using exponents as x to the 9th. Do we see a pattern yet? Maybe after this next example. All right, so we have just x. All right. I mean, some people could see that's x to the 1st, right? So again, that's just x. We have x cubed, so that's x times x times x. We're going to multiply those together, and that's going to give us x to the 4th. All right, so can we think about a rule that we can use going forward with these problems where we are multiplying these exponential expressions? All right, so again, if you were thinking that, hey, notice that they both have the same base, our answer is going to have that same base. All right, so here we're multiplying the same base, so we know our answer is going to be that same base. To find the exponent to our answer, we are going to add the exponents. Just like we did here, 3 plus 2 gave us 5. 5 plus 4 gives us 9. 1 plus 3 gives us 4. All right, so then rather than write this out in expanded form, we can use this general rule of product of a power and say, all right, so I'm going to multiply x to the 4th times x to the 8th. I'm going to keep the base, and I'm going to add the exponents. So I got x to the 14th times x to the 9th times x to the 5th. I'm going to keep the base, and I'm going to add the exponents. Okay. Okay, so we're going to stop there for today. Let's go ahead and transition into the homework for tonight.